This is the OCR GCSE 9 to 1 Maths Paper 1 covering the foundation tier, and it's from the November 2019 series, and this paper is a calculator paper. Question number 1. For part A we have to write down the mathematical name of this quadrilateral. Well, what you can see is two of the sides are parallel to each other, and therefore what we have here is a trapezium. Now for part B, we have to write down the mathematical name of this solid. Of course, what we have here is a sphere. Question number 2. For part A, we have to complete this list to show all the factors of 30. Well, 1 times by 30 is 30, 2 times by 15 is 30, 3 times by 10 is 30, and 5 times by 6 is also 30. And now for part B, we have to write down the highest common factor of 25 and 30. Well, if we think about the factors of 25, we have 1, 5 and 25. And therefore for the highest common factor of 25 and 30, indeed, what we'd have here is 5. Question number 3. Line AB is shown on this coordinate grid, and for the first part of part A, we have to write down the coordinates of point A. Well, for point A, we are going 4 across, 9 up, so therefore the coordinates will be 4, 9. And then for the coordinates of B, we are going -2 in the x direction and -3 in the y direction, and therefore the coordinates of B will be -2, -3. For part B, we have to plot C, where we've got the coordinates 7, -2, so we've got 7 across, -2 down. Here is the point C. And for part C, the equation of the line AB is 2x plus 1 equals y. A line parallel to AB goes through the point 0, 4. We have to write down the equation of the parallel line. Well, first of all, if the line is parallel, that means the gradient of this new line is the same. We'd have the same gradient of 2. So we've got y equals 2x, and the y-intercept when x equals 0, the y-intercept here, you can see is 4. So we've got y equals 2x plus 4. Question number 4. A theme park asked 900 people to choose their favourite activity from a list of 5. The pictogram shows the results for 4 of the activities, and we've got this key over here. 4 little boxes like this represents 100 people. How many chose entertainment for the first part of part A? Well, we've got 100 plus another 100, so that's 200 in total. And then, how many more people chose water rides than family rides? Well, for water rides, we've got 100, 200, and then each little square, that will be worth 100 divided by 4, which is 25. So we've got 100, 200, and 75. So water rides, we've got 275, and for family rides, we've got 100 plus 25, which is 125. So now, the difference between these, 275 take away 125, that's 150. So we've got 150. And then for the third part, all 900 people chose one of the 5 activities. We have to complete the pictogram. So here, for thrill, we've got 100, 200, and then 250. So that's what we've got here for thrill rides. Here for family, we've got 125. Here we've got 200 for entertainment. For water rides, we've got 100, 200, and 75. And therefore for children's rights, if we've got 900 in total, 900 take away the 250, take away the 125, take away the 200, take away the 275, it turns out here we get 50. And so if each little square represents 25 people for 50, we would have something looking like this. So here is, if we just draw the line like that, here is children's right. Now for part B of the question, we'll place a game at the theme park. There are 20 cards numbered from 1 to 20. Will takes a card at random. If he wins if the card he chooses is a prime number. We have to work out the probability that Will wins. Give your answer as a fraction in its simplest form. Well, what we need to do first of all is identify the prime numbers between 1 and 20. The definition of a prime number is a number that can only be divided by itself and 1. Well, 1 isn't a prime number because it's only got 1 as a factor. 2 is the only even prime number, and then we've got 3. 4 isn't a prime number. 5 is, 6 isn't, 7 is, 8 isn't, 9 isn't, 10 isn't, 11 is, 13 is, 17 is, and 19 is. So here are the prime numbers from 1 to 20, and you can see here we've got 8 prime numbers between 1 and 20, and therefore the probability that we have a prime number, so the probability that he wins, is equal to 8 over 20, which is equal to 2/5. So we've got 2/5 as the correct probability. And now for part C, a family ticket for the theme park costs £68. If the ticket is bought online, it costs 15% less. How much does it cost to buy a family ticket online? Well, what we can do first of all is work out 15% of 68. 15% of 68, this will equal, we can just use our calculator, we've got 0.15 times by 68, which is 10.2. And therefore, 15% off 68 will equal 68 take away 10.2. So we do 68 take away this, which is 57.8. So we've got 57.8. So therefore, a family ticket purchased online will cost £57.80. Question number 5. For part A, we have to simplify 4a plus 5a minus 7a. Well, in total, you can see we would have 2a. And for part B, we have to simplify 3g minus 2f plus 8g plus 8f. Well, in terms of the g's, we have 3g minus plus 8g, which is 11g. And then we have minus 2f minus plus 5f, which is 3f. Question number 6. We have to write down the inequality shown on this number line. Well, you can see here, x is going to be less than 2. And the reason it can't equal 2 is because we have a circle here which isn't filled. So we've got x being less than 2. For question 7, we have to factorize fully for part A 6 plus 9y. Well, over here, the highest common factor of both terms is 3. So 3 times by 2 gives a 6, and 3 times by 3y gives the 9y. So factorizing 6 plus 9y, we get 3 lots of 2 plus 3y. And for part B, factorising 2x squared plus 6x, well, in terms of the numbers, the highest common factor is 2, and in terms of the letters, well, both terms involve an x, so we've got 2x as the highest common factor, and then 2x lots of x gives the 2x squared, and 2x lots of 3 gives the 6x. Question number 8. Plaza United are playing a football match away from home. 379 supporters are going to the match by coach. Each coach seats 45 people. What is the smallest number of coaches that will be needed? Well, what we need to do over here is find out how many 45s go into 379, and that will tell us how many coaches we need. And to do that, we can do 379 divided by 45. So we've got 379 divided by 45, which is 8.422, etc. And therefore what you can see then is we need 9 coaches. Now for part B, in their last 50 matches, Plaza United have drawn 10 matches, lost 5 and won the rest. Sam claims the probability that Plaza United will win this match is 0.7. Show calculations to support Sam's claim. Well, if we find out the number of winning matches, well, they play 50 matches, 10 of them are draws, 5 of them are lost, so we've got 35 which are wins, and therefore the probability that we win, we've got 35 over 50, which is equal to a value of 7 over 10, which is indeed 0.7. So we've got 0.7 as our probability, and then we have to give one reason why Sam's claim may not be reliable. Well, the best players may now be injured, which is one reason why his claim may not be reliable. Question number 9. Mr. and Mrs. Jones buy cinema tickets for themselves and their 3 children. The cost of an adult ticket is £6 more than a child ticket. The total cost of the 5 tickets is £45. We have to work out the cost of an adult ticket. We begin by letting an adult ticket equal x. So this will imply then that a child ticket is equal to x minus 6, because an adult ticket is £6 more than a child ticket. So a child ticket is £6 less than an adult, hence we've got x minus 6. So we've got 2 adults, so we've got 2 lots of x, and then we've got 3 children, so we've got 3 lots of x minus 6, and then in total we get 45. So we've got 2x plus 3x minus 18 equals 45. So we've got 5x minus 18 equals 45. 5x, that's equal to 45 plus 18, which is 63. And if we divide through by 5, you will find x to equal 63 divided by 5, which is 12.6. So the adult ticket costs £12.60. Question number 10. The area of a parallelogram is 4 times the area of a triangle. So we've got here the triangle having a base of 4 and a height of 6 centimeters, and a parallelogram having a base of L and a height of 3. So what we need to do to find L is find out the area of both the triangle and the parallelogram. So for the area of a triangle, we've got 1/2 times by 4 times by 6. In total here we would get 12 centimeters squared, and we're told that the area of a parallelogram is 4 times the area of the triangle, so the area of a parallelogram, that's equal to 4 times by 12, which is 48 centimeters squared. Now to work out the area of this parallelogram, what we need to do is multiply 3 by L. So this here is equal to 3L, and if we divide both sides by 3, you can therefore find L to equal 16. So we've got L equals 16 centimeters. Question number 11. Harry has a job. On Friday he is paid £8.50 per hour. On Saturday he is paid 1.5 times that rate. He works for 4 hours on Friday. He works from 8 AM until 1 PM on Saturday. How much does Harry earn in total for these 2 days? Well, on Saturday his rate of pay then will be £8.50 times by 1.5. So if we work this out, 850 times 1.5, that's 12.75. So he gets paid £12.75 per hour. This is on a Saturday. Now, if he works on Saturday from 8 AM to 1 PM, you can see in total he works 5 hours, and therefore he will earn, well, we've got £8.50 on Friday, and he's working 4 hours on Friday. So here is the situation for Friday. And then on Saturday, we've got the £12.75 times by 5 because he's working 5 hours. So here is the situation for Saturday. So if we work out the total here, we've got this amount times by 5 plus 850 times by 4, which is £97.75. So we get here £97.75 as the total amount of money he would earn. So we've got £97.75. Question number 12. The volume of a cube is 125 centimeters cubed. We have to calculate the total surface area of the cube. Give the units of your answer. Well, what you can see here is our cube. The volume is 125 centimeters cubed, and therefore the length of one side will equal the cube root of 125. So if we work this out, the cube root of 125, we get 5. So we've got 5 centimeters by 5 centimeters by 5 centimeters. What we can now do is find out is the area of one face. That will be 5 squared, which is 25, and therefore to work out the surface area, that's equal to, well, we've got 6 faces multiplied by 25, so here we would have 150 centimeters cubed. So we've got 150 centimeters squared for the total surface area. Question number 13. Here is a right-angled triangle, and we've got a length here of 20 centimeters and another one of 14 centimeters. We have to calculate the value of x to the nearest, but we have to show that the angle x is 35 degrees, correct to the nearest degree. Well, what you can see here is the 14 would represent the opposite, the 20 would represent the adjacent, so therefore we have tan x equaling the opposite 14 over the adjacent 20. We need to find out what x is. So x is equal to the inverse tan of 14 over 25. So if we work this out, we've got the inverse tan of 14 over 25, which is 29.248, etc. Rather, 14 over 20, which is 34.992, etc. So therefore, to the nearest degree, we have 35 degrees. To the nearest degree. Question number 14. Dean drives a distance of 760 kilometers in 9 hours. Robert drives a distance of 559 kilometers in 6 hours 30 minutes. Who has the highest average speed? Show how you decide. Well, first of all, we know that speed is equal to distance over time. So we can find out each of the speeds based upon this relationship. So if we consider Dean, for his average speed, we have the distance 760 kilometers divided by the time, which is 9 hours. So if we work this out, 760 divided by 9, you'd find that to be 84.4, etc. kilometers per hour. And if we consider Robert, well, his average speed, well, we've got a distance here of 559 kilometers. And his time, well, we've got 6.5 hours over here, because 6 hours 30 minutes is the same as 6.5. So here we've got 6.5 hours. So 559 divided by 6.5, you'd find this to equal 86. So over here we've got 86 kilometers per hour. And therefore, when we come to see who has the higher average speed, we can conclude Robert would have the higher average speed because the 86 kilometers per hour is greater than the 84.4, etc. kilometers per hour. Question number 15. Andrea is 165 centimeters tall, correct to the nearest centimeter. Joel is 170 centimeters tall, correct to the nearest 10 centimeters. Show that Andrea could be taller than Joel. Well, if we consider the interval for Andrea's height, well, what we would have here is, if it's to the nearest centimeter, we'd have 164.5 being less than or equal to his height being less than 165.5. So this is for Andrea. Okay, so let's just write that down. Here is the situation for Andrea. And for Joel, what we would have here, if it's to the nearest 10 centimeters, we'd have over here 165 being less than or equal to J being less than 175. So therefore, what you can see is a possible pair. Well, it's possible that Andrea has a height of 165.4 centimeters and Joel has a height of 165 centimeters, and you can see which one's greater. So Andrea could be taller than Joel. So Andrea could be taller than Joel. Question number 16. Carol makes birthday cards. Each card takes the same amount of time to make. She makes 3 cards in 48 minutes. She has an order for 80 cards. Can she complete this order in 3 days if she works 8 hours each day? Show how you decide. Well, if she's working at a constant rate, then she can make 1 card in, well, here we'd have 3 cards in 48 minutes, so 1 card will take 48 divided by 3, which is 16 minutes. So 1 card takes 16 minutes. And we're questioning if she works 8 hours a day, can she complete this order in 3 days? Well, if she works 8 hours a day, well, to go from hours to minutes, we'd have to multiply by 60 and minutes to hours would have to divide by 60. So this 8 hours that she works each day, this is the same as 8 times by 60, which is 480. So she works 480 minutes each day. So therefore what we can do is find out how many cards she can make in 1 day. So therefore in 1 day we'd have 480 divided by 16. So 480 divided by 16, this is 30. So she can make 30 cards in 1 day. Now in 2 days, she can make 60 cards because in 1 day she makes 30 cards, and therefore in 2 days she can make 60 cards, and therefore in 3 days she can make 90 cards. So what you can see is she's got 80 cards to make, and in 3 days she can make 90 cards. Well, clearly she's got enough time to make 80 cards, because at most she can make 90 cards in 3 days. So because this is 80 then greater than the 80, we can therefore conclude that she can complete the order. Question number 17. The table below shows the area in square kilometers of some countries, and for part A we have to write the area of Sweden as an ordinary number. Well, if we take a look at Sweden, we've got 4.50 times 10 to the 5. So we begin with the 4.50, and then we're going to move this 1, 2, 3, 4, 5 places to the right. And if we fill the rest of these with zeros, you can see then we have 4, 5, 0, 0, 0, 0 as the area. And then we have to find out which of the above countries has the smallest area. Well, that's quite easy. If we take a look, looking at the smallest power of 10, that will be Singapore. So therefore Singapore has the smallest area. And now for part C, Alexis says the area of Australia is approximately 3 times larger than the area of Luxembourg. Is she correct? Show how you decide. Well, if we compare the area of Australia to Luxembourg, well, what you can see here is, to find out how many times it's bigger, well, we've got 7.69 times by 10 to the power of 6 divided by 2.59 times by 10 to the power of 3. So if we work this out, we've got 7.69 times 10 to the 6 divided by 2.59 times 10 to the 3. So it turns out here we get 2969.11, etc. So therefore, Alexis she's incorrect because it is approximately £3,000 bigger. And now for part D, we have to work out the total area of Russia and Australia. Give your answer in standard form. Correct to two significant figures. Well, if we take a look at Russia, we've got 1.71 times by 10 to the 7. And if we take a look at Australia, we've got 7.69 times by 10 to the power of 6. So adding these together, this will tell us the total area. So we have 1.71 times by 10 to the 7 plus 7.69 times 10 to the 6. So here we get 247,900,00. And if we write this in standard form, well, if we move this decimal place 1, 2, 3, 4, 5, 6, 7 places to the left, we would have 2.479 times by 10 to the power of 7. So if we write this in standard form to two significant figures, we have 2.5 times by 10 to the power of 7. And this is of course given to two significant figures. Question number 18. Bob makes dry concrete by mixing cement, sand and stone in the ratio 1 to 2 to 3 by weight. He buys the cement, sand and stone in bags as shown in this table. So for cement we've got a weight of 25 kilograms. It costs £5.50 for the bag. For sand we've got a weight of 20 kilograms. It costs £2 per bag. And for stone we've got a weight of 15 kilograms and it costs £3.90 per bag. He packs the dry concrete into 30 kilogram bags. Bob buys just enough cement, sand and stone to make 50 bags of dry concrete. For part A, we have to show that Bob buys 500 kilograms of sand. Well, if we use this ratio, we can find out the total number of parts. So, the number of parts will equal 1 plus 2 plus 3, which is 6. So we have 6 parts. And what we can do is find out the total weight we need. So, for the total weight, we would have 30 multiplied by 50, which is 1500. So we've got a total weight of 1500 kilograms. And therefore, 1500 divided by 6, if we work this out, 1500 divided by 6, this is equal to 250. So we've got 250 kilograms per part. And therefore, to find out how much sand we need, well, we've got 2 parts here of sand, and therefore for sand, we would need 2 times by 250, which is 500. So we have 500 kilograms, and this is for the 50 bags. Now for part B, Bob sells the 50 bags of dry concrete for a total of £396. We have to calculate Bob's percentage profit. Well, if we go back, what we can do is find out how much cement and stone we also need. So for cement, we would have, well, you can see here for cement we've got 1 part. So therefore we've got 1 times by 250, which is 250 kilograms. Again, this is for 50 bags. And for stone, we would have 3 times by 250, which is 750 kilograms. So this again is for 50 bags. So now what we can do is find out the number of bags we need for cement, sand and stone. So for cement, let's just write this down here. For the bags for the cement, well, for 50 bags we've got over here 250 kilograms, and a weight of a bag is 25. So what we need to do over here is divide 250 by 25. So 250 divided by 25, that's equal to 10. And therefore, the cost here, we would have 10 multiplied by 550, which is £55. For sand, well, we had here 500 kilograms, and then what we will do is divide this by the 20. So 500 divided by 20, that's equal to 25. So we know as well that it costs £22 per bag, so we would have 25 times by 2, which is 50. And then for stone, we would have 750 divided by the 15. So 700 divided by 15, you'll find this to equal 50. So therefore, we would have over here 50 times by 390. So therefore, if we work this out, 50 times by 390, let's just work it out on our calculator. We get 195 pounds. And therefore, for the total cost, we would have 55 plus 50 plus 195. So if we work this out, so if we add on 50 and 55, it turns out here we get a total cost of 300. So therefore, for the percentage profit, we would have the change over the original times by 100. So we've got the change, which is 396 take away 300, and then we divide this by 300, and of course times by 100 after. So therefore, for the percentage profit, we would have 396 take away 300, and then divide this by 300, and then times by 100, we get 32%. So the percentage profit, you can see, is 32%. Question number 19. 12 students take 2 tests. Each test is out of 60. The scatter diagram shows the results for 10 of these students. And for part A, the table shows the results for the other 2 students. So we've got test 1 and test 2. And we've got their marks as well. And we have to plot these on a scatter diagram. So for this student, we've got 36, 44. So if we plot this, 36 is over here and 44, that will be over here. And then for the other student, we've got 38, 41. So 38, that's over here somewhere, and 41, that goes here. So what we've done here is plotted those 2 points, and now for part B, we have to describe the type of correlation shown in the scatter diagram? Well, as you can see, as test 1 increases, the other also increases, and therefore you can see we'd have a positive correlation. And now for the first part of part C, we have to draw a line of best fit on the scatter diagram. So for a line of best fit, we want to go through as many points as possible, so we'd have something like this for the line of best fit. And then we have to, for the second part of part C, we're given that another student was absent for test 2. The student scored 40 marks on test 1. We have to use our line of best fit to estimate a result for this student on test 2. Well, if you got 40 on test 1, well, what we can do is draw a line vertically up from 40, as we see here, and then we draw a horizontal line going across. So therefore what you can see then is we've got a test mark 2 of 40. And for part D, we have to work out the percentage of the 12 students whose result on test 1 is lower than their result on test 2. So here, what we have to do is take a look at all 12 students, and we want test 1 to be lower than test 2. So test 1 being smaller than test 2, well, test 1 is lower than test 2 here, 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 and also here. And we've got 1, 2, 3, 4, 5, 6. So what we've got here is 6 scores which are lower than test 2. So therefore we'd have 6 out of 12 times by 100. So if we work this out, 6 divided by 12 and then times by 100 would have 50%. So you can see here we have 50%. And obviously values can vary depending on how you've drawn your scatter diagram. So here we'd have 50%. Question number 20 for part A. Are these two triangles definitely congruent? Give a reason for your answer. Well, what you can see is that although the corresponding angles here and here, also here and here, and also here and here, although over here we've got the corresponding angles being the same, the problem is we don't know the lengths, so we can't conclude that they are similar. Rather, we can't conclude that they're congruent. We can conclude that they're similar, but we can't conclude that they're congruent. So no, because the lengths are unknown, all we know is that the triangles are similar. And now for part B, we have to prove that these two triangles are congruent. Well, first of all, what you can see here is the angle HGI is equal to KJL. So let's just write that down. HGI equals KJL, which is equal to 36. What we also can see is HG equals KJ, which is 9 centimeters, and what we can also see is GI equals JL, which equals 7 centimeters. You can see we've got side, angle, side, and therefore you can see that the triangle HGI and the triangle KJL are congruent. So that's the end of the paper. Don't forget to like, share and subscribe, and any questions feel free to comment in the comment section below, and hopefully I'll see you on the next video.